In this question, we have to find the length of a cycloid for one rotation. Of course, we need to know what a cycloid is to begin with. A cycloid is basically what a circle traces as it rolls on level surface. So you can assume the x-axis is where the circle is rolling, okay, and as it rolls past the x equals 0 point, this point travels in this fashion. You can imagine if there was a pointer over here and that pointer was tracing this path, this would be the path we'd get. The parametrization of the cycloid is interesting because as time goes on, or you can think of it as the angle goes on, the x and y coordinates tend to change. Now, the x as a parameter t, as a function of parameter t, is the radius of the cycloid times t minus sine t, while the y component of t is r1 minus sine t. Okay, so 1 minus cosine t. Okay, so you can see that as the parameter t is 0, both x and y are 0, so this starts from 0, 0 position in the xy coordinates. These equations can be simply proved by geometric arguments that I'll leave to you. Now, given these two equations or the parametric forms of the cycloid curve, we have to find the length. Now, how would we find the length? The length of a parametric equation, as you've studied, is from the lower limit to the upper limit, of course, of the parameter times the square root dx by dt squared plus dy by dt squared dt. So we need to find the derivatives of x and y parameters, variables with respect to the parameter t. We just simply plug them in. Dx by dt, as you can see, r is a constant because it is the radius of the circle that's moving. So this becomes 1 minus cos t, whereas dy by dt would become cos has a derivative of minus sine, so it would become r sine t. If you plug all of this in, this would become, there's an r in both of them, there would be an r square, and then after the under root there would be an r outside, so we can just take that out already. And then there's 1 minus cosine of t, which would be squared, so I can just write 1 plus cos square t plus, sorry, not plus, minus 2 cos t, the expansion, and then sine square t. These two things we know add to 1, so this is going to be r 0 to 2 pi 2, because this is 1, 1 plus 1 is 2, 2 minus 2 cos t dt. And you can see, you can take the 2 common and you can retrieve the form which is given over here. And a is assumed to be the radius, however there's not much description to the question, which there should be. But that's how you figure out the length of the cycloid. It's a very simple integration exercise from here on, because it's a cos function and it's a constant function. You can evaluate the integral. You should be able to prove that the length of one cardioid cycle is 8r. I hope you can do that. It's a very simple integral and you'll get that value. This is one cycle, and then the cardioid starts over and does the same thing over and over again.